This is Advanced Math, Unit 9, Lesson 6. You should have this printout from class. If not, go back to the website and print it off the website. 9.6 Conjugate Root Theorem. If a plus the square root of b is the root of a polynomial function, then a minus root b is also a root of the same function. And the same works with a plus bi, then a minus bi is also a root. We've talked about that before. Okay, find all, so we're looking for imaginary solutions as well if they exist. Find all roots for each function and sketch. Use Descartes and rational root theorem. Indicate multiplicity for each root if other than 1. All right, I am going to do the plus minus I chart first. Plus minus I. This is Descartes' rule of signs. Okay, so number of sign changes. There's 1, there's 2, and that one doesn't count, so 2. 2 minus 2 is 0, and I can't go any smaller than that without becoming negative. And I flip-flopped these, sorry. Plus, minus, I. Okay, minus. I'm going to go through and do p of negative x. Plugging a negative in there would be negative x cubed. Plugging in a negative in there would square it, become positive, leaving the 2 negative. That would become minus 5x, and 26 will stay as is. 1, actually that doesn't count, so none, none, 1, just 1. And then when I can't decrease, because decreasing would give me a negative number if I decrease by 2, so it's just 1. All right, my degree is 3. 2 plus 1 plus 1 is 3. So 2 are positive, 1 is negative. And that does not sound right. Sorry. I'm rushing and I should not be. All right. My degree is 3. 2 plus 1 plus 0 is 3. And I knew that 1 was wrong because I've told you guys these should always end up being even. All right. 2 plus 1 plus 0 is 3. 0 plus 1 plus 2 is 3. So my two different scenarios are 2 are positive, 1 is negative, 1 is 0, none are imaginary. 0 are positive, 1 is negative, and 2 are imaginary. All right. Plus minus factors of 26 over factors of 1. Factors of 1 are only 1, so it's just going to be the factors of p. What goes into 26? 1, 2, 13, and 26. And it would be all of those over another factor, but the only other factor of 1 is another 1, so it's just these. All right, I'm just going to start off and just guess negative 2. If you want to hit pause and try numbers on your own, you're more than welcome to. Make sure you use your original function. Third power, second power, first power, no power. That's 1, negative 2, 5, 26. Drop that down. That's a 1, negative 2, negative 4. That is a positive 8, 13, negative 26, 0. So that does work, and I got this down to 3, so I don't have to guess anymore. Now let's say you had tried negative 1 first, or positive. Why did I start off with a negative number? I know for sure that I have one negative solution. I know that for sure. There is a possibility that I have no positive. I could have 2, but there is a chance that I have no positive, and I might be wasting my time guessing positives. So that's why I went straight to the negative, because I know for sure I have at least 1. You should try negative 1 first. You could. I just went to negative 2. It worked. 1x squared minus 4x plus 13 equals 0. Can't factor that, so I'm going to complete the square. You can use quadratic if you'd like. X squared minus 4x plus blank equals negative 13 plus blank. What you add to one side, you must add to the other. Negative 4 cut in half is negative 2. Negative 2, sorry, wrote that wrong. Negative 4 cut in half is negative 2. And when you square negative 2, it becomes 4. So 4 on that side and 4 on that side. All right, x minus 2 quantity squared equals negative 13 plus 4 is negative 9. Square root, x equals 2. I guess I shouldn't be jumping steps. X minus 2 equals plus or minus 3i. The square root of negative 9 is 3i. Move your 2 over 2 plus or minus 3i. All right, so list all the roots. All of my roots are the one I found there, the real root, negative 2, and then the 2 imaginary, 2 plus or minus 3i. All right, so I ended up with 3 roots, 1, 2, 3. One was negative, and 2 were imaginary, and none were positive. So this right here is the scenario we ended up with. None were positive, 1 was negative, and 2 are imaginary. In conjugate root theorem, if 2 plus 3i is a solution, 2 minus 3i is automatically going to be a solution, because when we square root, we plus or minus. All right, so what does this graph look like? Negative 2. My y-intercept, when I plug in 0, plug it into the original, 0 minus 0 plus 26. I'm running out of room. Y equals, that was 0 minus 0 plus 0 plus 26. Y equals 26 is your y-intercept. So I know it's positive 26. Do your end behavior and your high-low stuff. It's cubic, so it's going to be either low-high or high-low, because the degree is odd. It's positive, so it's low-high. Okay, so here's the deal. If we just went up like this, it just looks like a regular cubic function. And we do have an imaginary solution. Now, x to the third would be just a regular cubic function. X to the third minus 2x squared plus 5x plus 26 with imaginary solutions means you have a bump somewhere in your graph. So as long as you start low and you do this and then you put a bump somewhere, it doesn't matter how or where, as long as you put it in there somewhere. I mean, I just erased it to show you can redo it, but it's up to you. As long as there's a bump in there somewhere to show that you have your imaginary solutions. We started low, we ended high. I hit my 1x intercept, and it was a multiplicity of 1, so it's a cross. I never bounce on a y-intercept. I always cross it. Cross the y-intercept, put a bump because of the imaginary solutions. If you put it on this side instead, that's perfectly fine. There's your solution. All right, we're going to skip number 2. Number 3. G of x, blah, 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 hint 6 is an upper bound. They give us an upper bound. What does that mean? That means I'm not going to guess anything higher than 6. Okay, plus minus I, plus minus I. 1, 2, 3, 4. 4 sign changes. There's 1, 2, 3, 4. Comma, 4 minus 2 is 2. 2 minus 2 is 0. I can't go any smaller than that. Do your g of negative x. That's going to stay positive x to the 4th. That's going to become plus 10x cubed because that negative does not go away, multiplied by that negative. This will stay plus 28x squared. That'll become plus 30x and then plus 75. And how many sign changes? None. And then imaginary, okay, by degree is 4. So if all 4 are positive, there's no negatives and no imaginaries. If 2 are positive, then and none are negative, then 2 have to be imaginary. 2, 0, 2 is 4. And the last one, 0, 0, 4. 0 plus 0 plus 4 is 4. 2 plus 0 plus 2 is 4, and 4 plus 0 plus 0. You can do what we were doing in notes the other day if you wanted to kind of help visualize. It's 4, 0, 0, 2, 0, 2, or 0, 0, 4. What I notice is that there are no negatives. So when I do my P over Q, I'm not going to worry about putting plus or minus because it can only be positive. All right, positive, I usually put plus or minus, but I'm not going to. They're all positive. Factors of 75 over factors of 1, that's nice because 1 is only 1. So the factors of 75 would be 1, 3, 5, 15, 25, and 75. Again, I would typically put plus or minus, but I'm not because there's no way there's going to be any negative solution, so I would be wasting my time. 6 being an upper bound is really nice because I can cross out anything bigger than 6, so I'm not going to waste my time. So the list that would have been 1, 2, 3, 4, 5, 6 would have been 12 numbers long because of positive and negatives has now reduced down to just 3. Why? Because this eliminated half, and then this eliminated 1, 2, 3, another half of the half, so we're down to just 3 possible real rational solutions, 1, 3, and 5. All right, so guess a number, guess a number. Hit pause right now and try some numbers, and then hit play. I'm going to go ahead and work it out because I've worked it out ahead of time. I already know what would work. If you plugged in 1 already, 1 didn't work, so try 5. That would give you 1, negative 10, 28, negative 30, and 75. Fourth, third, second, first, no power. All the numbers are there. Trying to get 0 at the end. 1, 5, negative 5, negative 25, 3, 15, negative 15, and that is negative 75, which is 0. Now, I already told you that the 1 didn't work, and the only other one you can try is 3, and if you had tried 3, let's see what happens. 1, I'm going to bubble this in just in case the 3 doesn't work. I know what solution to come back to, what set of numbers. I don't go back to the original anymore. 1, 3, what is that? Negative 2, negative 6, negative 3, negative 9. That's not going to work. So 3 is not a solution. 1 is not a solution. What's going on? I have 5 as only one positive solution, but according to this, I have more. I don't have any only one positive. It's either 0, 2, or 4. So what that means is, and we've talked about this in class and in notes, sometimes a number can be a double root. So that 5 might work again. So I'm going to go back to this set of numbers, the one I bubbled so I didn't lose it. 1, negative 5, 3, negative 15, and that is 1. That gives me 5, 0, 0, 3, 15, and beautiful. It works beautifully. So we're happy. We got it down to 3. 1x squared plus 0x plus 3 equals 0, so that we can solve. Subtract the 3. X squared equals negative 3, and when you square root, you get plus or minus I root 3. So 2 negatives and 2 positives, we ended up with this situation right here. The 2 positives was the 5 and the 5, and the 2 negatives are the plus or minus I root 3. So x equals 5, parentheses, multiplicity is 2. They did ask us to label if it was bigger than 1, comma, plus or minus I root 3, which means we're going to have a little bumpy piece in our graph. Okay, so what ends up happening? It's even, the degree is even, so it's high, high, or low, low. It's positive, so it's going to be a high, high. If you're not understanding where we're getting that, you want to make sure you ask for help. Plug in 0, 0 minus 0 plus 0 minus 0 plus 75. Your y-intercept is going to be 75. Positive 75, and my x-intercept is positive 5, and it is a bounce, and it's a bounce because the multiplicity is 2. Okay, so I'm starting high. I come down and hit the 75. Now I can't just come down, sorry. I can't just come down like this and go up because that's just a regular x squared function, And this is not a regular x squared function. It's x to the fourth with all this excess stuff. So and it has imaginary solutions, which means there's some bumps in there somewhere. Where you put them is up to you. As long as you put some bumps in there, it's not a complete, nice, pretty U shape because of the imaginary solutions. It's not an x squared function. If all of that was gone and it was just x to the fourth, it would be a U shape. But with all this excess stuff and the imaginary solutions, you get some bumps going on. Okay, let's flip over to the back side. Number 4, find all roots for each function and sketch. Used a CART rule. Okay, same as the front. We're going to continue doing the same thing. Plus, minus, I. I'm actually going to have you guys try this one on your own. I'll circle it. I'll come back and do it with you guys. Do the whole thing the best you can. You know for sure it's going to be high because the degree is 4 and it's even. So you know that. And then do your plus minus I, factors of 16 over factors of 1, and go from there. Number 5, I do want to go over write the equation or function with real coefficients that has the given zeros. I just want to make sure that we remember how to do this. We know for sure there's going to be and x minus 3, parentheses, and x plus 1. And this piece right here, we don't know what it is, but we know whatever it is, once I solve it, negative 2y is going to be a solution. Now remember the conjugate root theorem. If negative 2y is a solution, so is positive 2y. They may not give them all to you, but you should know if one is there for an imaginary solution, so is the other. Same with square roots. Okay, so is its conjugate. So what we've done before is we've done x equals plus or minus 2i. And if you just put 2i, you'd get the same answer. There's nothing to move over, so I'm going to go straight to squaring both sides. X squared equals positive squared or negative squared is positive. 2 times 2 is 4. I times I is I squared. And 4i squared is negative 4, remembering I squared is negative 1. Move the 4 over. X squared plus 4 equals 0, and that's what goes right in there. X squared plus 4. Do you see how that worked? And if I were to solve this, subtract 4, square root both sides, I'd get the plus or minus 2i. All right, I'm going to have you guys try 6 on your own. I know for sure it's going to be f of x or g of x or y. I'm just going to use y this time, equals x plus 7. I'm going to write it quantity squared because there's 2 of them. And then this blank. And this is going to be whatever you get here. Don't forget there's also a 3 minus I root 5. That's hiding. Again, if you didn't write it, you would be okay, because if you just did x equals 3 plus I root 5 and solved it, you would get this regardless. I'm still going to put the plus or minus. So subtract the 3, square both sides, move the number over, and finish it off on your own. All right, find all roots for the given polynomial, blah, 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 blah. This is on the test, and a lot of kids miss it, so you want to make sure you're paying attention. List all the roots. Okay, they only gave us this one. This one is new. This one we haven't seen. Everything so far has been kind of review. And they gave me the function. I can use long division or synthetic if possible to find the other factors, but I need to get this to look like this or like that missing piece there. So first thing I do is x equals 5 minus 2i. Move over your 5. Square both sides. That's kind of what you would be doing up there. X minus 5, x squared minus 10x plus 25 equals negative 2 times negative 2 is 4. I squared, 4i squared is negative 4. X squared minus 10x plus 25 equals negative 4. Move the 4 over. X squared minus 10x plus 29 equals 0. Okay, so this is one of the factors of this function. Now, in order to find the other factors, I have to use long division. And the reason I use long division is because synthetic wouldn't work, because it's an x squared function. So x squared minus 10x plus 29 divides into, and the reason I'm looking for the other factors is so I can solve and find the roots. It's a lot to this problem. All right, so I'm going to divide this into the original 6x cubed minus 55x squared plus 124x plus 145. And you do your long division. I'm going to let you guys hit pause and do your long division. Because I'm running out of time and the bell's about to ring, there it is. I'm going to give it to you, 6x plus 5, but you should show your work and check that you get it. So I will do that with you guys in class, and we'll finish off these two as well. But I do want to write the actual solution. Find all the roots. Set this equal to 0. 6x plus 5 equals 0. You get negative 5/6, comma, what else did they give you? Now, if you just put 5 minus 2i, you're going to get it wrong. The reason is the conjugate root theorem. If 5 minus 2i is a solution, then so is 5 plus 2i. So 5 plus or minus 2i. Now, I didn't say it earlier only because I was waiting to see if any of you figured it out, but over here, technically, this should be 5 plus or minus. I would have gotten the same thing either way because plus or minus 2 squared is still going to be positive 4. All right, I'll talk more about this one because this is a definite, and I will do these two, and I will go over these two with you to make sure you guys did them correctly. That is it for this lesson.